Looking at this expression, we have a lot of different variables, and it's asking us to factorize fully. That's a bit of a hint. So factorizing fully means you don't stop factorizing until all the common factors have been pulled out. So just looking at these first two terms, what common factors do you see? So start with the numbers, the coefficients, so 4 and 2, and then look at the variables, bx and xy. So between 4 and 2, that's a common factor of 2. Between the variables, I see an x to the power of 1, right? Because when we don't have the power, it's just implied 1. So I see a common x. And then what are we left with? So 2x times what gives us 4bx. Well, we'll need a 2 to get the 4, and we'll need a b. Right, and just double check, 2 times 2 is 4, x times b is bx. So that works. And then 2x times what gives us 2xy. That one is just y, right? And again, just check by expanding, because expanding is the opposite of factorizing. So if you factorized correctly, expanding it should get you what you started with. And now we can look at the next two terms. Again, looking for the highest common factors. So between -6 and -3, that will be -3. Between AB and AY, that would be an A. And then what are we left with? So -3a times what gives us -6ab, positive 2b. -3a times what gives us -3ay. That's just positive y. So that's factorizing once. And now, hopefully you will have noticed, looking at this expression, we see 2b plus y appear twice. So that is now a new common factor. So what we can do, like before, is pull out that common factor. So 2b plus y. And now 2b plus y times what gives us this first expression, this first term, excuse me. Well, it's just 2x. 2x. And then 2b plus y times what gives us -3a times 2b plus y. Well, that will be -3a. So to summarize this one, we had more variables than just x, let's say, so it's not a simple like quadratic factorization. Here we looked at two terms at a time to get common factors, and then we looked at the whole expression to get another common factor. And again, expanding is the opposite of factorizing, so when you get to here, expand it out, and you should get back to where you started. So I'll leave you to do that one to check.